All right, so welcome to the Gate Academy English channel, my dear. Welcome to the Gate Academy English channel. So, beta, here I am again with the live quiz with timer of theory of machine. Okay, so we already had few sessions of live quiz with timer of theory of machine and fluid mechanics as well. Now, today we are going with one more session of live quiz with timer of theory of machine. So, my dear, my name is Umashankar Tripathi, and today I'm going to conduct this quiz for you guys. Okay, so if you have not like and subscribe the channel, please like and subscribe and share to your friends so that many students, more students can come to this live quiz session and we can play the quiz. Okay, so now first of all, how we can play this quiz? Okay, so as you can see the link given at the top of the screen, bit.ly tga071e. Okay, so what we have to do, we have to go to this link and we have to register ourselves. Okay, so how to register ourselves? No email ID, no mobile number will be required. Just you have to write your number and we are good to go. You just have to write your name and we are good to go, right? So, my dear, you can open this link on any other device. Like if you are watching me on the mobile, you can open this on the laptop. If you are watching me on the laptop, obviously you can open this on the mobile, or you can do it in another video. If you are watching me on mobile only, then you can use the option of split screen, right? So in this quiz we are going to have four questions, and there will not be any negative marking with any of the question. Okay, so every question will be assigned some points, and that point will be displayed along with the question. Obviously, more tougher the question, more will be the points assigned. And also, as the name suggests, this quiz is with timer. So here, time is also a very important aspect. So sooner you answer, more marks you will get, more points you will get. So as we know, in competitive examination, not only we have to give the correct answer, we have to give it in a given time frame. Okay, so here we have associated the questions with time. So sooner you answer the question, more points you will be getting. Okay, okay, so please join all the live students here. You can play this quiz live with me on the Gate Academy YouTube channel, my dear. So please join the quiz. Please join the quiz so that we can start the questions. Okay. So we have few students already joined. So let's begin. Let us begin. Okay. So here we go with the first question. So the first question is MCQ question. The first question is MCQ question. Okay, first question is MCQ question, and what we have to find in here, we have to find, we have to find, we have to find the inertia of the flywheel, right? We have to find the inertia of the flywheels. So please go for it. So in MCQ question, only one option is correct. So we need to answer, we need to give the answer to the correct option. Just one correct option is required, so we need to give the answer to the correct one. All right. Please go for it, beta. I'm very assured that you guys can solve this question. Right. Please go for it. Please go for it. I'm very sure we guys can solve this question, beta. Please go for it. This is a MCQ question. This is a MCQ question. Okay. So in GATE, we have NAT, we have MSQ recently added, and now we have MCQ question as well. Very simple question, very basic question of flywheel. So we have already have some answers. So we can find the answer to this question. Very simple, direct formula based question. We see these kind of a question in 1 marks mostly. Please try to solve this question, my dear. I'm very sure we can do it, beta. I'm very sure that we can do it. Please go for it. All right. So all of you have answered to this, and let's see how many of you have given the correct answer. So I see Keshav and Manisha, both of you have given the right answer to this question. Very nice. Tanay Hayat, you were not able to give the right answer. Don't worry, try with the next question. Okay, so here we go with the next question, with the second question. And this is a MSQ question, my dear. This is a MSQ question. Okay. Okay, so in this MSQ question, beta, in the MSQ question, I hope we are aware that this is a new addition to from Gate 2021. Before Gate 2021, we do not had these kind of a questions. Okay, now after 2021 in 2022 also we have these questions of MSQ, multi-select question. In these kind of a question, more than one option is correct. Okay, so that means maybe all four may be correct. Any three of them may be correct. Any two of them may be correct, or only one may also be correct. Okay, okay. So sometimes the student asks me, sir, that if we give partially correct answer, like let's assume that all four are correct, and we have marked two as correct. So will we get some marks out of it or not? So you won't get any marks. All right, you won't get any marks, my dear. Either your question should be completely correct, okay, then only you will be getting marks, or you will be getting 0 marks. No negative marking associated with MSQ and NAT questions. Please go for it. So we have a 4-stroke engine, as you see in the figure. You have to solve, this is particularly a numerical question, and in this numerical questions, few things are asked. So definitely, I think you can do it if you try. Please go for it, beta. I'm very sure that we guys can do it. Please try it. Please try it. I'm very sure we can do it. Please try for it. Please try. So I just got 2 answers till now. Rest of you can also answer, my dear. Very simple, very basic question. So we have a T theta diagram of 4-stroke engine. Okay. So obviously in this suction compression area is not given. So definitely we can neglect that. Exhaust area is also not given. We can neglect that. So we have only one power producing area, that is the expansion one. So time is going to get up, and this time is up, beta. Time is up. All right. So all four were correct. Now let's see how many of you have given the correct answer to this. So Keshav, you have given the correct answer to this, beta. You have given the correct answer to this one. Very nice. Very nice. So no worries, beta. This is just to make you check, or to make you realize that where you are lagging behind. So I hope you get. So we'll be solving all these questions in the end of the quiz. Okay. Now we can do this also. So it is a question of what governor. Okay. Governor question. Let's see if we can solve it or not. Please try. Please try, my dear. I'm very sure we can do it. Please go for it. So we know we have some governors now, ward governor, porter governor, proel governor. So let's see if we can do it. Please try it, beta. Please try it. 2 minutes are remaining, beta. We can solve this. Please go for it. Please go for it. Please go for it. Two answers have come, my dear. So in a numerical data type question, we have to write the answer. Sayan, my dear, you can join the quiz and answer in there. Though if you want a confirmation, the answer is wrong, beta. Very basic question, my dear. So in this, so we know in the governor what happens when the speed changes, the sleeve moves, and when the sleeve moves, the radius of governor will solve this question, sir. No worries. After completion of the quiz, we'll be solving the question. Okay. So by this time, you can try yourself to answer this. Okay. So what I was saying, so in governor, my dear, Sayan, if you are a CSC student, my dear, this is not meant for you. This is a fluid mechanics question, so that is not meant for you. Okay, so we got few correct answers. So Manisha and Keshav, both of you have given the correct answer. Very nice, beta. Very nice. So let's see one last question in this quiz session, and then we can solve these questions. Okay. So again, a question of a governor. So on the x-axis, this is r. This is the radius of the governor. Please make the connection. Correction. This is r here. On the horizontal axis, this is r, and this is the controlling force. So you have to judge whether the governor is stable, unstable, or isochronous, or if you cannot judge, or we can't judge by the information given. Let's see if we can solve it or not. Please go for it. This is the last question in this session, my dear. This is the last question in this session. So we need to judge it whether it is a question of whether the controlling force diagram given to you. So this is the controlling force diagram. I hope you understand. This is a curve. So basically, it is of either could be of watt, porter, or proel governor, right? For a spring control governor, the controlling force diagram is a straight line. Now, from this curve, we have to judge whether it is stable governor, unstable governor, isochronous governor. Let's see if we can do it or not. Please go for it. Let us see if we can do it or not. Please try it, my dear. I'm very sure we can do it, beta. I'm very, very sure that we can do it. One minute remaining, my dear. Please answer it. So again, it is a multiple choice question. So only one option would be correct. And you have to choose any one of it. All right. Let's see how many of you have given the right answer to this. Still, all of you have not answered to it. Please go for it, my dear. Please try. 20 seconds remaining. Okay, so time is up. Okay, so let's see how many of you have given. So Manisha and Keshav, both of you have given the right answer to this question. So very nice, Keshav. You are topping the chart. Manisha, you also have played very well, beta. Okay, you also have played very well, and you have given the answers correctly to mostly all the question. Now let's see what is the solution to this question. Okay, so I am hoping we can see the one note now, right? Okay, very nice, beta. So now let's see the solution to these questions. So this is the first question. This was the first question. The speed of the engine varies from 210. The speed of the engine varies from 210 to 190 radian per second. During this, the kinetic energy, the change in kinetic energy is found to be 400 Newton meter. The inertia of the flywheel. So we know the change in kinetic energy is I omega square Cs, right? Right. So what is the change in kinetic energy? It is 400 Newton meter I. What is this omega? So omega is what is this n? What is the average speed? So average speed is obviously 210 plus 190 by 2. That is 200 radian per second. Okay, so this is your average omega, right? So because it is given in radian per second, so directly we can write it as 200. What is this CS, my dear? So CS is omega max minus omega min by omega. So you can put this value of CS here, and when you will be solving this equation, when you will solve this equation, so you will be getting the inertia of the flywheel as 0.1. I hope it is fine to you. Now moving to the second question, my dear. Moving to the second question. So in this question, first of all, what we can do. So basically, what is the procedure? Okay, so what is the procedure? So first of all, we have to find the work done per cycle. So to find the work done per cycle, we can find the area under T theta diagram. So what is the area under T theta diagram? So the area under T theta diagram is nothing but the area under this triangle. So this is 7,500 mm square. So we need to convert it in Newton meters. So we are having 22500 Newton meters. So work done per cycle. So that is second B option is correct. Now we know that work done per cycle is also equal to T mean into the duration of the cycle, that is 4 pi into 2250. So I think if you do it, you will be getting the mean torque. You will be getting the mean torque as 1790.49. So that is mean torque is 1790.5. Okay. Now, what is the maximum torque in the cycle? So the maximum torque would be, this is the maximum torque in the cycle. So how we can find this maximum torque? So we know the area of triangle is half base into height. So the area of this triangle is given to be 7,500 into 3 is equal to half. Base of this triangle is pi and the height is T max. So from here we can find the T max. From here we can find that T max. So it is 2 by pi. So we are getting it as, okay, 7,500 into 3 into 2 by pi. So we are getting 14323.9. So that is nearly 14324 Newton meter, right? So maximum torque, this is also correct. And we always know that, so this is your T mean line. So we know that the fluctuation of energy is area above or below T mean line. So the area above T mean line is maximum fluctuation of energy here, right, beta? So this is the maximum fluctuation of energy. So that is, this is also correct. So in this question, all four options were correct. Understood, beta? Now moving to the next question, the change in vertical height of a watt governor in mm when speed increases from 60 rpm to 61 rpm, right? So we know that height of the governor is given by 895 by n square. 895 by n square, and if you put the value of n, you will be getting the h in meter here. So if I say h1 is 895 by n square, that is 60 square, and h2 is 895 by 61 square, right? So now what will be the change in the height? What will be the increase in the height? So you can write it as h2 minus h1. Okay, so if you calculate it, you will be getting 0.008 meters, 0.008 meters. So just you have to put the values here and calculate. So 0.008 meter, it means 8 mm. So here you have to give answer in mm. So the answer is 8. I hope it is fine to you. Directly formula based question, right? Now moving to the last question. So the controlling force diagram. So this is, as I said, this is the radial. So the control force diagram shows that the governor. So how we check beta? We draw two speed lines, right? So this is N1, this is N2. So obviously N2 is greater than N1. Okay, we know it. Now what is the radius corresponding to it? What is the radius corresponding to it? So this is N1 and this is N2. So let's call it R1, R2. So we see R2 is also greater than R1. So what we can say, with its increase of speed, radius is increasing. So when with increase of speed, radius is increasing, so that means it is a stable governor. So how we check from controlling force diagram? We simply can draw two speed lines and can check whether with the increase of the speed the radius is increasing. So if it is increasing, it is a stable governor, and if otherwise it happens, so it is a unstable governor, and if the radius is not changing, it is a isochronous governor. So this is the stable governor. This is what? This is a stable governor. Is it fine to everyone or not? Please answer me, beta. Please answer me. So any doubt in any question you guys may ask me, beta. Any live student, if you feel that sir, we have any doubt in any question, we can have it again, we can solve it again. So I am hoping that there is no doubt, my dear. So thank you very much, and do not forget to like and subscribe. And in case of any information regarding the upcoming batches and anything like that, any suggestion, any query for the test series, okay, you can visit our website or you can call on this number, okay, or you can mail your feedbacks to us, okay. So thank you very much, and we'll see you in the next session.